So welcome to Yogi's lectures. I hope all of you are safe. So in this session we have discussed about the Wien bridge oscillator. So it is the type of oscillator which consists of two stages of amplifier circuit and feedback network. Feedback network is a balanced Wien bridge circuit which does not produce any phase shift. So like RC phase shift, it doesn't produce any phase shift. Frequency range vary by changing the capacitor value. So here we have a circuit diagram. So this is the first term, second term, third, fourth. So in this R1 and C1 are in series, C2 and R2 are in a parallel, and R3 and R4 for the voltage dividing purpose. So here we have a two stages of amplifier circuit which is coupled to the coupling capacitor Cc. So and then finally we can get a output V0 here. So this is the general circuit diagram, and then we have a Wien bridge circuit alone. So here we have, this is a Z1 and Z2. This Vf is nothing but feedback voltage, and then Vin is nothing but input voltage. So here ground. So Z1 and Z2. So the feedback network consists of R1 C1 in series, R2 C2 in shunt, and R3 R4 as a voltage divider circuit. The two arms of Wien bridge Z1 and Z2 are frequency sensitive amps. So as earlier said, it doesn't produce any phase shift. So if you want to change the frequency, means we want to change this capacitor's value or C1 and C2. If change this capacitor value, we can get a higher frequency. And then so Wien bridge circuit is otherwise known as lead lag network. So at a low frequency act as a lead network, and at a high frequency it act as a lag network. So in this oscillator, two stage CE amplifier circuit is used to produce 0 degree or 0 to 360 degree phase shift. So if produce a 0 to 360 degree phase shift means, so it have a sustained oscillation to produce the output. So derivation for frequency of oscillation, the series impedance is given as Z1, which is equal to R1 plus 1 divided by j omega C1. So which is equal to 1 plus R1 j omega C1 divided by j omega C1. This is equation number 1. The shunt impedance is Z2, which is equal to R2 parallel 1 divided by j omega C2. So which is equal to R2 into 1 divided by j omega C2 divided by R2 plus 1 divided by j omega C2. So here we can take a LCM. So R2 into 1 divided by j omega C2 divided by R2 j omega C2 plus 1 divided by j omega C2. So this j omega C2 and this j omega C2 will be cancelled. So and then we can get a Z2, which is equal to R2 divided by 1 plus R2 j omega C2. This is equation number 2. The current in the feedback network is I is equal to Vin divided by Z1 plus Z2. The feedback voltage is given by Vf, which is equal to I into Z2. So Vf is nothing but Vin divided by Z1 plus Z2. So into Z2. So this is equation number 3. Feedback gain of Wien bridge oscillator beta, which is equal to Vf divided by Vin, which is equal to Vin divided by Z1 plus Z2 into Z2. So into 1 divided by Vin. This Vin and Vin cancel. So we can get Z2 divided by Z1 plus Z2. This is equation number 4. So beta is equal to R2 divided by 1 plus j omega C2 R2 whole divided by R1 j omega C1 plus 1 divided by j omega C1 plus R2 1 plus j omega C2 R2. So which is equal to, here we can take again a LCM. So R2 divided by 1 plus j omega C2 R2 whole divided by 1 plus j omega R1 C1 into 1 plus j omega C2 R2 plus R2 into j omega C1 whole divided by j omega C1 into 1 plus j omega C2 R2. So this term and this term will be cancelled. So So which is equal to j omega c1 r2 whole divided by 1 plus j omega r1 c1 plus 1 plus j omega r2 c2 plus r2 j omega c1. So beta is equal to j omega c1 r2 whole divided by 1 minus omega square r1 r2 c1 c2 plus j omega r1 c1 plus r2 c2 plus r2 c1. The above equation can be simplified by the rationalizing the expression. So if want to rationalizing means we want to take a complex conjugate of this term. So beta is equal to j omega r2 c1 divided by 1 minus omega square r1 r2 c1 c2 plus j omega r1 c1 plus r2 c2 plus r2 c1 into 1 minus omega square r1 r2 c1 c2 minus j omega of r1 c1 plus r2 c2 plus r2 c1 whole divided by 1 minus omega square r1 r2 c1 c2 minus j omega r1 c1 plus r2 c2 plus r2 c1. So r1 c1 plus r2 c2 plus r2 c1. So which is beta is equal to omega square r2 c1 plus r2 c2 plus r2 c1 plus r1 c1 plus j omega r2 c1 into 1 minus omega square r1 r2 c1 c2 whole divided by 1 minus omega square r1 r2 c1 c2 plus omega square into r1 c1 plus r2 c2 plus r2 c1 the whole square. So this is equation number 5. So at resonant condition we know XL is equal to XC. So then we can equate the imaginary part equal to 0. So omega r square c1 into 1 minus omega square r1 r2 c1 c2 the whole divided by 1 minus omega square r1 r2 c1 c2 the whole square plus omega square r1 c1 plus r2 c2 plus r2 c1 the whole square which is equal to 0. So omega r2 c1 into 1 minus omega square r1 r2 c1 c2 the equal to 0. So if you this term goes opposite side means equal to 0. So 1 minus omega square r1 r2 c1 c2 is equal to 0. If we want to know omega value, so this negative term goes outside that side means omega square r1 r2 c1 c2 which is equal to 1. So omega square which is equal to 1 divided by r1 r2 c1 c2. So we can take square root omega which is equal to 1 divided by square root of r1 r2 c1 c2. So f is equal to 1 divided. So condition for oscillation beta is equal to omega square r2 c1 into r1 c1 plus r2 c2 plus r2 c1 whole divided by 1 minus omega square r1 r2 c1 c2 whole square plus omega square r1 c1 plus r2 c2 plus r2 c1 the whole square. So this is we can equate that real part. So if r1 r2 which is equal to r and c1 c2 which is equal to c, so substitute these values in the above equation, we can get beta is equal to omega square rc into rc rc rc, so 3 rc whole divided by 1 minus omega square r square c square plus omega square into rc plus rc the whole square. So which is equal to 3 into r square c square omega square whole divided by 1 minus omega square r square c square whole square plus 3rc the whole square omega square. So from this we can get, so this equation 3r square omega square c square whole divided by 1 minus omega square r square c square the whole square plus 9 omega square r square c square. This is equation number 7. So substitute the equation 6 in 7. So we can get beta is equal to 3 into 1 divided by r square c square into r square c square whole divided by 1 minus 1 divided by r square c square into r square c square the whole square plus 9 into 1 divided by r square c square into r square c square. So from this we can get beta is equal to 1 divided by 3. So this is the perfect condition to match the oscillation. So thank you.